Today I'm going to be talking about limiting and excess reactants in a chemical reaction. I'm going to start off by using an analogy here to kind of give you an idea for really what a limiting and what an excess reactant is. If I were going to make a cheeseburger, if I wanted to make one cheeseburger, I know we would need buns and burger and cheese, and you could throw other things on there if you wanted for this example, but to keep it pretty simple, we're going to say it's going to take buns, burger, cheese to make a cheeseburger. Now with the buns, we're going to count the top and bottom separately, so we're going to say it takes 2 buns, 1 burger, and 1 cheese to produce 1 cheeseburger. So we go to work at a fast food restaurant and we go back there and we look on the counter and there's 20 buns, 15 burgers, and 12 slices of cheese. And our job here is to make cheeseburgers. So you might be able to look at that and kind of think it through and come up with the answer using some logic. We're going to do this the same way that we would approach a problem in terms of limiting and excess reactants with stoichiometry. I'm going to do a couple different problems here and kind of show you how we would go about this if we were doing limiting and excess in a chemical reaction. The first thing I would start with is my 20 buns, and I would say, okay, how many burgers can that make? So I'm going to use a ratio here. I'm going to go from buns to cheeseburgers. All right, and it's 2 buns makes 1 cheeseburger, or 1 cheeseburger results from 2 buns. So if I multiply across the top, I get 20, 2 on the bottom. That gives me 10 final product cheeseburgers. All right, that's just from the 20 buns. All right, now I'm going to do this again. 15 burgers. From burgers, I'm going to go to final product cheeseburgers, and that is, looking back here to my balanced equation, that's a 1-to-1 ratio. So 15 times 1, 15 over 1, that gives me 15 product cheeseburgers. The final problem here is 12 slices of cheese, and according to my equation, 1 cheese will give me 1 cheeseburger. So 12 times 1 over 1 equals 12. So I've got one scenario that gives me 10 products, one that gives me 15, and one that gives me 12. When I look at this, if I've got one that gives me 10, I am limited by the 20 buns. So in this reaction, this is my limiting reactant, and these other two things are excess. Now, I'm going to go through the math to go ahead and verify that the burgers are excess. I'm going to go back to my limiting reactant because sometimes we want to know, okay, what do we have when we're done? Well, I know right now I've got 10 cheeseburgers when I'm done, but I want to know what else I'm left. What's still sitting on the counter? What am I left with? So I'm going to go from 20 buns using this ratio up top. There's 2 buns needed for every 1 burger, so that tells me that I need 10 burgers to make that. So I've got 15, so if I need 10 and I have 15, that tells me that in fact there's 5 of those left over when I'm done. And you would do this real similar reaction, or maybe just use logic. You would say there's 2 excess slices of cheese here as well. So this is a limiting reactant because it determines how much we can actually produce. And we need to be aware for chemical situations that when we're done, there's still other things that are present. There's the excess burgers, excess cheese that's left here. All right, so switching this to a chemical reaction that maybe you're pretty familiar with. This is the combustion of magnesium. We're just going to talk right now in terms of whole number of moles. So we're going to balance this equation. 1 magnesium, 2 oxygen, 1 oxygen, coefficient 2 fixes the oxygen. Now I got to come back and fix the magnesium. 2 magnesium for every 1 O2 molecule, 2 magnesium oxide. So let's suppose that I'm given 4 moles of magnesium, 3 moles of O2, and I want to know how many moles of magnesium oxide I can expect to produce from that. Same thing that we just did. We take our given 4 moles of magnesium, 2 moles of magnesium in this ratio will give me 2 moles of magnesium oxide, and I could reduce that ratio down to 1-to-1. 4 times 2, 8 on top, over 2 is 4. So that's going to give me 4 moles of magnesium oxide. Let's look at the second one. If I have 3 moles of O2, moles of O2 to make it cancel is going in the bottom. I'm going to go to moles of magnesium oxide, and that is from the equation 2 magnesium oxide for every 1 O2. 3 times 2, 6 on top, over 1. Gives me 6 moles of product. So again, very similar to the cheeseburger situation here. Do I get 4? Do I get 6? I am limited by the 4 moles of magnesium. So that's going to limit me to 4 moles of product because of that. I want to verify that the oxygen is excess, and I want to see how much oxygen is excess. So I'm going back here to my limiting reactant, 4 moles of magnesium, and I want to see how much oxygen I need. So from moles of magnesium, I want to go to moles of O2. Up top, 1 O2 for every 2 magnesium. 4 times 1 is 4 over 2. Tells me I need 2 moles of O2. I have 3, so not only did I identify from here that it was excess, but now here I need 2, I have 3, so I know that there's 1 mole excess oxygen once I've done this. I'm going to do this same problem a couple different ways. I'm going to do this next in terms of Legos. So here are my 4 moles of magnesium. Here's my 3 diatomic oxygen. And I want to see how many magnesium oxides I can build. Well, magnesium oxide is 1 magnesium for every 1 oxygen, so I'm going to snap those together. There's a magnesium oxide. Another magnesium oxide, break another O2 apart, another, and another, but notice I'm left with the 1 excess mole. I form 4 moles of magnesium oxide, but I'm left with the 1 excess mole of oxygen. Again, for some calculations in the future, knowing that excess and being able to use that value is very, very important. If we don't have Legos handy, we can also do this by shapes. I can say, okay, well, let's have 4 moles of magnesium. I'm going to make that 4 boxes. O2, and we'll use circle, circle, 3 diatomic oxygens. And I want to put those together just to simply make magnesium oxide. I'm going to cross them off as I do. So I need 1 magnesium, 1 oxygen to make the first one. Another magnesium, another oxygen. And another, and another. And 1, and 1. So notice I get 4 product moles, same thing we've shown mathematically and also shown with the Legos, and there's still 1 O2 that's left here, so there's an excess diatomic oxygen present. All right, so now we're going to look at this in terms of grams and a little more involved stoichiometry, not terribly difficult, but a little more involved. If I have 5 grams of magnesium, 5 grams of oxygen, how much magnesium oxide will it make? Well, this is where we got to know our gram to mole ratio. So from grams of magnesium, we're going to have to find moles, because when we write and balance the equation, magnesium plus oxygen makes magnesium oxide. Those are coefficients, but they're also our mole ratios. They're not a gram ratio. Those are a mole ratio. So I've got to take these grams to moles, and I do so using the molar mass. So again, here I've got 2 problems, 5 grams of each. Probably not as simple as 10. The only way it would be 10 is if these were mixed in the right mole ratio, meaning neither of these were limiting, neither being excess. So I'm going to start with 5.0 grams of magnesium. I want to see how many grams of product that I'm going to get. Grams of magnesium, I'm going to go to moles of magnesium using the molar mass on the periodic table. 1 is 24.31. Then from moles of magnesium to moles of magnesium oxide, that's the 2 to 2, or I'm going to go ahead and reduce it, 1 to 1 ratio. And lastly, moles of magnesium oxide to grams of magnesium oxide, and I'm going to add up 16 for the oxygen, 24.31, which is going to be 40.31 grams per mole. Grams of magnesium cancel, moles of magnesium cancel, moles of magnesium oxide cancel, leaving me with grams of magnesium oxide. And now I'm ready to multiply across the top. 5 times 1 times 1 times 40.31. And on the bottom, 24.31 times 1 times 1. And when I divide by the bottom, I end up with, in doing 2 sig figs, I end up with 8.3 grams of magnesium oxide from 5 grams of magnesium. Still don't know if that's the answer until I work with the oxygen. 5.0 grams of O2. From grams of O2, I'm going to go to moles of oxygen as well. 1 mole is, oxygen is 16, but since it's diatomic, it's 32.00 grams per mole. From moles of O2 to moles of magnesium oxide, that ratio is 2 magnesium oxide for every 1 O2. And lastly, very similar to the previous problem, 1 mole of magnesium oxide has a molar mass of 40.31 grams. And now I'm ready to grab the calculator and crunch the numbers again. 5 times 2 times 40.31 on top is 403.1. And then on the bottom, 32 times 1 times 1 is 32. And that gives me 12.6 grams of magnesium. So if I take a look at this, one gives me 8.3, the other gives me 12.6. That tells me that the 5 grams of magnesium is my limiting reactant. The oxygen is excess. My answer is 8.3 grams of magnesium oxide. I want to go ahead and verify that. I want to see how much oxygen is left there. If I were going to draw this, do some kind of a particle view drawing, I would want to know not only how much product I get, but how much excess oxygen reactant would still be present. So from this, I'm going to take the 5.0 grams of magnesium and see how much oxygen I need to react with that. So from grams of magnesium to moles of magnesium. Very similar to the first problem we did. 1 is 24.31. Now for moles of magnesium, I'm going to go to moles of oxygen. That ratio is 2 oxygen for every, or 1 oxygen for every 2 magnesium. And lastly, moles of oxygen to grams of oxygen, and that is 32.00 grams per mole. 5 times 32 on top, and on the bottom we're going to divide by the product of 24.31 times 2 times 1. And it ends up showing me that I need 3.29 or 3.3 grams of oxygen. I have 5, so if I take a look at that, I've definitely got excess. As a matter of fact, there's 1.7 grams of excess oxygen present. So that verifies the oxygen is in fact excess. I can also do another problem down here in case you happen to mess up in identifying limiting an excess, just to show you what it looks like. If I had went from the oxygen backward to the magnesium, 5 grams of oxygen from grams of oxygen to moles of oxygen, 1 is 32.00. From moles of oxygen to moles of magnesium, kind of the reverse of the previous problem here. For every 2 magnesium, I need 1 oxygen. And then lastly, from moles of magnesium to grams of magnesium, 24.31 grams per mole. And if I solve that bottom problem, on top I end up with 243.1. And on the bottom, 32 times 1 times 1 is 32. And that tells me that I need 7.6 grams of magnesium. And if I go back to the problem, I don't have enough. So again, that verifies the 5 grams of oxygen would need 7.6. So I don't have enough. It is limiting, all right, which again, we've already proven with the prior calculations.